Well, in the last video, we finished creating this controller object, which handles our basic controls by default, the WASD keys, if we don't pass anything into the constructor. And that's going to be the only one that I add to Panda 3D for my uses. But something we're going to want to do is create custom scripts and add those in as we go. So might as well have that ready to test before the next adding stuff to the game writer object and the methods for the interface methods. So go ahead and do that in this video. And one other thing that I wanted to spread out across two videos is, well, we gave it a test run last time, and there's something special we have to do the very first time. It applies to Panda 3D, but it actually applies to lots of game engines when we work in our normal IDEs. So the very first time it runs, the operating system creates a reference to it. And the IDE needs that reference. So the very first time we run, and this applies to a lot of game engines in a lot of IDEs, I'm pretty sure Eclipse is an exception to that because Eclipse is set up to go with Java by default. So it automatically creates that reference in the background since by default it's intended to go with the Java virtual machine. So NetBeans would probably be a similar thing, but in a lot of IDEs, the very first run has to happen in a system terminal, a command prompt or command line or in bash. So we want to go into configure, where we configure our run and make sure and execute in the system terminal once. So set up that configuration, then it just opens this, well, I'm on Windows machine, so it opens the command prompt, opens the window, but now we have that reference. So in order to use things like our variable explorer, we need it to run in the IDE. So we can, once it runs once, both the IDE and the operating system know about that reference, so we can use it over and over again. That applies to a lot of game engines on a lot of IDEs, so just make sure you're aware of that. Then afterwards, we could execute in our local console, or I like to execute things in a dedicated console. With Spider, if it's in the main console, a lot of things the window will open behind the IDE. So in a dedicated console, will open in front. So now we should be able to switch over to a dedicated console and give that a run here locally. So it opens a new console, which takes just a second because it has to connect to the kernel. And there it is. So now we're able to run that game locally, which means we have our variable monitor is going to work. And I like to run in a dedicated console because then to clear that one I can just do that. So now just make sure you run the very first run in pretty much any IDE you're working on. And it happens on a lot of game engines, so just take it as a rule of thumb. The very first run of a game in an IDE, run in the system terminal, not the local console. Then after that, you'll be able to run in the console. So now let's create a custom script to consolidate all the stuff about this actor, because that's something we want to do in games, kind of a cleanup thing and consolidate all of our player objects into one thing, which is not going to be a keep around game object for the project. So I'm going to close this, go ahead and close these files, and I'll just do that right over here in the console, because I have that method, I have that class generator here in the file we're working in. So I can just go ahead and import that. Import class generator. And now kind of create the custom script, because this is a method I want to add to the interface so that we can, well, call that method from a console or attach a button to a graphical user interface, depending on how this project ends up at that point. But let's see, now that we have that, we can call it the start whoops, I imported it that way, didn't I? So class generator dot start class, and I'll just put it in a little custom module. I'll just call it player. Then give it a name. I'll call it player. That seems a good name for it. And the predictive thing is kind of in the way. So put it in a module called player. I'll just call it player. It's not going to have a parent at this point. And then pass in the attributes for it. And the attributes for this is, well, to get to our control thing like we did down here, we'll need to pass in a watcher because this character is going to be there. So we'll need a watcher attribute, and we can't set a default on that. The watcher cannot be passed in until runtime because that comes from the operating system. So that has to be first because everything else we'll be able to set a default on. And then just all the stuff we have for this. So I'll just go ahead and pass in the actor. Whoops, those are supposed to be strings. Pass these in as strings so that little method I wrote can generate the start to the class, all the getters and setters. Then we'll pass in a control object, an instance of that thing we just created in the last couple videos. Then what we have here, this is walking variable, or I think we call it is moving in this case. And then a linear speed and angular speed. Linear speed and angular speed. And as the interface comes together, there'll just be a method that writes all of this. I think that's all I need from here. So there's an actor to it. This stuff's going to be in the actor. Have to reparent it afterwards. Boolean, we'll have the actor object, so we'll be able to get the animation controls. Yeah, then this method will get copied over to it, and this method will get copied over to it. So that should be everything we need. I just need a linear and angular speed, and then turn and step, and this target angle and the new position, those will all be local to that method. So go ahead and run that. Whoops, I forgot a closing parenthesis. Now run that. One of the nice things about the IPython console, as opposed to the regular Python interpreter, so now we should have a script called player. There it is. So created that for us, and we can set in some default values. So I'm going to go ahead and put default values where we can. So some of these are going to copy right over from what's in that method. So angular speed will default to 3. Linear speed from testing 0.01 seemed to match the animation. Is moving, well, it's not going to move to begin with. Control, I'll just start with a default control 3D object, which means that needs imported. So up here, import game objects. Oh, import all from game objects. We'll do it that way. The actor, I want to go ahead and set up a default actor, which I happen to have over here in images. I did create a little default BAM file to work with that has an animation. It's a sphere that's yellow with a smiley face, and it just kind of nods its head back and forth. So I'm going to set that as the default actor. And we have a constructor for the actor over here we can copy from. That way there's some sort of default value. So I'll just hit Shift End to copy that and bring that in as a default value. And then the watcher we can't pass into runtime. So I get some default values on everything. And remember in Python, the things without default values have to go first. So the watcher has to be passed in every time because we'll need that for our control method, our move method, or our controller really. And then that we can should be able to just copy from here. Both of these. Well, I'll copy them one at a time because I think the indenting level is going to be off. I'll put that here. Oh no, it indented at the correct level. And then on the next one, do this. And just like they were done in the original logic, I'm going to pass those over to the task manager eventually. So now we can make a couple changes. So where the original one said human, that's our actor. And we have an actor. So we could call underscore underscore actor. But since there might be inheritance, it's better to call the get actor. That way any child objects of this will be able to call their own actor instead of the parents. So in Spider, it's Control R for find and replace. So Control R, and look for human and replace it with the get actor method. Looking at the highlighting, looks like it's highlighting all the right stuff. So replace all those. Could probably add some comments in here to kind of organize this long method. So like here is the, start right above that. Add a comment in here, actual move part. The animate part. A line above that. Then the control part. Just to help organize those. So linear speed and angular speed are included in our character. Oh, that was 0.05. I thought it was 0.01 for some reason. So I'll go up here and adjust that default value. 0.05. So a little faster than that first default I put in there. But now we can just change these things. So we have a control object, which would be underscore underscore or control. But again, if we want something to inherit from this, we need to call the get control to access it. And is walking, well, that's in our own thing, but it's a method now. So again, we can go to the find and replace is walking with our it is moving method. Looks like I highlighted all the right things. So replace all those. And then that's part of our object itself, not attached to the actor. So take that out. So just readjusting the logic, cleaning it up. Well, on our original one, we were able to reassign a value. So here we need setters to do that. Change that to set is moving, which would be true or false. And then we can take out that reassignment. So there's that. Oh, well, we're passing in a watcher, so we can, in our constructor, we have to pass in a watcher. So we can move that right to the character. And down here, I'm almost out of time, so I'll make these changes and talk about them afterwards. So just a couple changes here. So something we've already seen, that the get is moving is applied right to the self, so we were able to just take that get actor out of the middle, and then we didn't set up controls, so we have to do the actor.get in controls. And then one last thing, to change the default values here. So I'm going to change that, and I'll come back and talk about it in just a second. Actually, never mind, I'm not going to change that. This is a custom object. So I think we're ready to give it a test. We'll do that in the next video. See you then.